Okay, lesson 7.5, using the Pythagorean Theorem. So the converse of the Pythagorean Theorem, if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So when you learned about the Pythagorean Theorem, we talked about how this only works for right triangles. So if you're given all three sides, you could test the theorem and then see if it works. So here's example 1, identifying a right triangle. Tell whether each triangle is a right triangle. So looking at the green triangle, you can definitely tell which side is A, which side is B, and which side is C. So you go through the steps, and since you get 81 plus 1600 when you square 9 and 40, and you add those together to get 1681, which is also the square of 41, it is a right triangle. But on B, even though it does look skewed with the angles a little bit, you would definitely always know that the longest side is C. So 12 squared plus 18 squared would have to be equal to 24 squared, but when you add them together, it is 468, not 576, so it is not a right triangle. So if we're just given the measurements, and we're not even given the triangle, we can't even make a guess as to whether or not we think it looks like a right triangle or not. We just have to rely on the math. Knowing that the longest side length would be C, okay, that makes this 28 equal to C, and then this could be A and B. So 21 squared plus 20 squared would be equal to 28 squared. So 441 plus 400 equals, in this case, 28 squared is 784. When you add 441 and 400, you get 841. It does not equal 784. Therefore, the answer is no, not a right triangle. Okay. Again, looking for, in number 2, the longest side would be C. The other two can be A and B. 1 squared plus 0.75 squared must be equal to 1.25 squared. 1 plus, and then when you square 75, you get 0.5625. And this, when you square it, you get 1.5625. And so, therefore, when you add together, and they are equal, the answer is yes. This would form a right triangle. Another key idea in this lesson is the distance formula. The distance d between any 2 points, x1 and y1 and x2, y2, is given by this formula. So think about this, guys. We talked about this idea, if we look at the ratio of the change in y over the change in x, this is a lot like that, like the slope formula. We could tell the slope of the line. But if we think of it as right here in this picture, we're wanting the distance d, and we have 2 points, one right here and one right here, we could form a right triangle. Okay, forming a right triangle. Then you measure the distance here. The change in y becomes one leg. The change in x becomes another leg. So now we're using that slope formula in a little different way. So it's just like taking a squared plus b squared to be equal to c squared. In this case, c squared would be equal here. So don't let it get too confusing or scary. It's just saying that, the change in x now becomes leg A, the change in y becomes leg B, and when you find the distance between those 2 points, x1 and x2, that's the distance or the length of A that you would be squaring. So it just has a lot more variables, but it really means the same thing. And when you square that, and then you add to that the square of the distance, which would be equivalent to leg B, then you have to take the square root of all that to get the length of C. So we'll be working with that. So here's the points, 1, 5, and -4, -2. Let x1, y1 be 1, 5. x2, y2 be -4, -2. Putting it into the formula, you would be calculating the difference between the two x coordinates, -1 minus 2, and for the y coordinates, -2 minus 5. So you take the square of -5 and the square of -7, add them together to get the 74. When you take the square root of 74, it's not a perfect square, so we do not have to evaluate it or round it or estimate it, okay? Only evaluate perfect squares. So let's try a couple. I will write the distance formula up here. Okay, so you have big long square root symbol, and then you have x2 minus x1 squared plus y2 minus y1 squared. Again, this could be x1, y1, x2, y2 if you need help on figuring out where they go. So for 3, the square root of, you would put in here 4 minus 0 squared plus, sorry, my y looks a little bit sloppy here, so I didn't want to confuse you. 5 minus 0 squared. So this is 4 squared plus 5 squared when you take the difference inside the parentheses. So 16 plus 25 in this case is going to be equal to the square root of 41. The square root of 41 is not a perfect square, so we'll just go ahead and leave that as the answer. For 4, you would have 9 minus 7 squared plus 6 minus the -3 squared. Remember, this double negative means to add. So we get 2 squared, and 6 minus -3 is like 6 plus 3, or 9 squared. 4 plus 81 adds up to the square root of 85. Again, not a perfect square. In number 5, -5 minus the -2, which would be -5 plus 2, so that would be a -3 squared. And then we're going to have 1 minus the -3, or 1 plus 3. So here we have -3 squared plus 4 squared, 9 plus 16, which equals the square root of 25. So we can simplify that down to 5 as the distance between